Welcome to the Deep Dive. Today, we're looking at, well, the biggest thing in our sky, the sun. How exactly does it shine?
Right. We've been digging into this piece. How does the sun shine? Ho, the fiery truth inside our star.
Yeah, and our mission today is to really get to the heart of what powers it. Because, yeah, the first thought is just a giant fire.
Right. That's the intuitive idea, isn't it? Like a colossal bonfire.
But the actual science is quite different and honestly much more fascinating.
Okay, so let's start there. It's not burning like wood or coal.
No, not at all. It's mainly hydrogen, and its core is essentially a giant nuclear power plant.
A nuclear power plant. Okay, so what's happening inside that core? The audio mentioned extreme heat.
Extreme is an understatement. We're talking about 15 million degrees Celsius deep inside the sun. The pressure is also immense.
Right, and that heat and pressure force hydrogen atoms together.
Exactly. They fuse. Hydrogen atoms slam into each other with such force they combine to form helium. That's nuclear fusion.
Nuclear fusion. And during that process, something about mass. Yes, this is the crucial part. When the hydrogen fuses into helium, a tiny, tiny fraction of the mass just disappears. It's converted.
Converted into energy. Is that the Evans-Seiden thing everyone knows?
That's precisely it. That little bit of lost mass, m multiplied by the speed of light squared, c, equals a huge amount of energy, E.
Huge enough to power the whole solar system.
And then some. But this energy, it doesn't just pop out instantly. It starts a really long journey.
Yeah, I caught that hundreds of thousands of years just to get out of the sun.
It bounces around inside the sun, getting absorbed and re-emitted countless times in the radiative and convective zones. It's a very slow, random walk outwards.
So the light hitting us now actually started its journey ages ago inside the core.
That's right. But once that energy finally reaches the sun's surface, the photosphere,
It makes a quick dash to Earth.
a very quick dash, just about 8 minutes to cross the 93 million miles separating us.
8 minutes. That's incredible after such a long internal journey. So to be crystal clear for everyone listening, the sun shines because of nuclear fusion, not burning.
Absolutely. Before fusion was understood, scientists had other ideas, like maybe it was just contracting under gravity or chemically burning.
But those didn't add up.
Nope. They couldn't explain how the sun could possibly produce so much energy for so incredibly long. Fusion was the missing piece.
And it has been doing this for a long time. About 4.6 billion years, the source said.
That's the current estimate, yes. And it's got plenty of fuel left in the tank, so to speak.
Thankfully, about another 5 billion years of fusing hydrogen, roughly.
Roughly, yes. It's middle-aged in stellar terms.
But what happens after that? When the hydrogen in the core runs low, the audio mentions some dramatic changes.
Yes. Well, when the core hydrogen is depleted, the sun won't just switch off. It'll start fusing helium in a shell around the core.
And that changes things.
Dramatically. It causes the outer layers of the sun to expand enormously. It'll swell up into what we call a red giant.
A red giant. That sounds big.
Big enough, unfortunately, that it will likely engulf Mercury, Venus, and probably Earth, too.
Wow. So the source of all life on Earth will eventually consume it.
It's a sobering thought, isn't it? But it's billions of years away. For now and for a long time to come, that nuclear reactor in the sky is what makes life here possible. Without it, Earth would just be a frozen rock.
Okay, so let's wrap this deep dive. The key takeaway. The sun isn't on fire. It shines because deep in its core, immense heat and pressure cause hydrogen to fuse into helium.
And in that process, a tiny bit of mass becomes a vast amount of energy, which eventually travels to us as light and heat.
Exactly. Nuclear fusion powers our world.
And maybe a final thought to leave you with. Thinking about the sun having a lifespan, a beginning, a very long middle, but also an end, even one billions of years away,
Yeah.
really puts our own existence and even the existence of our planet into a different kind of perspective, doesn't it? How does that cosmic timescale make you think about permanence and change right here?